Hello friends, here we have to find the Jacobian of uv function with respect to two independent variables x and y, and we have to prove that this is equal to y square minus x square divided by 2uv bracket u minus v. Here you can see that the given functions are in implicit relation. Here the implicit relations are given with functions and the independent variables. So first we suppose that f1 is equal to u cube plus v cube minus x minus y, and f2 is equal to u square plus v square minus s cube minus y cube. Here you can see here the implicit relation between functions and variables is given. You can see here the implicit relation between functions and the variable is given. So first we suppose that this relation is equal to f1 is equal to u cube plus v cube minus x minus y, and the second implicit relation can be written as f2 equal to u square plus v square minus s cube minus y cube. When the implicit relation between functions and the variables is given, so first we suppose that the first relation is equal to f1 equal to u cube plus v cube minus x minus y, and the second relation is written as f2 is equal to u square plus v square minus s cube minus y cube. Now we find the Jacobian of the function f1 f2 with respect to u and v. You can see here Jacobian of f1 f2 with respect to uv can be written as, by the definition of Jacobian, del f1 by del u, del f1 by del v, del f2 by del u, and del f2 by del v. This is the second order determinant. Here we can see in this problem implicit relation between function and variables are given. Implicit relation means when functions and variables cannot be separated. Here you know that this function u cannot be expressed in terms of the variable x and y. Also v cannot be expressed in terms of the variables x and y. So these relations are called implicit relation. When implicit relation are given, then first we suppose that f1 is equal to first implicit relation and f2 is equal to second implicit relation. Now we find Jacobian of f1 f2 with respect to u and v. So by the definition of Jacobian we write del f1 by del u, del f1 by del v, del f2 by del u, and del f2 by del v. Now we find the partial derivative of f1 with respect to u, so this is 3u square, and partial differentiation of f1 with respect to v is 3v square. Similarly, partial derivative of f2 is 2u, and f2 with respect to v is 2v. Here we find in the first row there is partial derivative of f1 with respect to u. So partial derivative of f1 with respect to u is 3u square. When we differentiate f1 with respect to v, we get 3v square, and when we find partial derivative of f2 with respect to u, we get 2u, and when we find partial derivative of f2 with respect to we get 2v. Now we multiply this 3u square by 2v, we get 6u square v minus, when we multiply this 3v square by 2u, so this is 6uv square. Now taking common here 6uv, we get u minus v. So here first we find the Jacobian of f1, f2 with respect to uv. Now we find the Jacobian of f1, f2 with respect to x, y. So we find here Jacobian of f1, f2 with respect to x, y. So by definition, we write here Jacobian of f1, f2 with respect to x, y can be written as del f1 upon del x, del f1 upon del y, del f2 upon del x, and del f2 upon del y. So del f1 upon del x, you know that we find partial derivative of f1 with respect to x and y. So this becomes minus 1 and minus 1. And when we differentiate partially f2 with respect to x, we get minus 3x square, and differentiate partially with respect to y, we get minus 3y square. Now we solve this second order determinant. So this minus 1 multiplied by minus 3y square, so this minus multiplied by minus plus, this is 3y square. Similarly here minus 3x square multiplied by minus 1, so this will be 3x square. Now taking common 3 here, we get 3 times y square minus x square. So this is the Jacobian of f1, f2 with respect to x, y. Now here we have to find the Jacobian of uv function with respect to x, y. So here we use formula. Here we write minus 1 to the power 2, because this 2 means there are number of variables. There are 2 independent variables x and y. So in powers of minus 1 we use here 2. And we write here del f1 f2 upon del uv del f1 f2 upon del x y and del f1 f2 divide del uv. This is the formula when we applied the given relation is implicit relation. Here we have to find the Jacobian of uv with respect to 2 independent variables x and y. So this will be equal to minus 1 to the power 2. 2 means there are 2 independent variables x and y. So we write here 2. If there are 3 independent variables, so we write here 3. If there are 4 independent variables, we write here 4. And in the numerator, we write Jacobian of f1, f2 with respect to x and y. And in the denominator, we write Jacobian of f1, f2 with respect to uv. This formula is used when the relation are given in implicit form. So this minus 1 square becomes plus, and Jacobian of f1 f2 with respect to x y, this is given by 3 times y square minus x square, and Jacobian of f1 f2 with respect to uv is given by 6 uv times u minus v. You can see here this 6 is cancelled by 3. So this is equal to y square minus x square by 2 uv and u minus v. So this is the Jacobian of uv function with respect to two independent variables x and y. Thank you.